Paulo, do you want to take it away from me?
Great. Thank you. Appreciate it. So, hi everyone. It's so good to see some familiar faces. To be honest with you, as I'm getting older, I'm getting a bit more emotional, so that means a lot to me. So thank you for coming. I'm here to talk about custom runtime and container support on Lambda. Like it was mentioned before, there will be 2 presentations today. Just a few things for you to know. So the first thing is, the knowledge that you acquire from the first presentation will be very useful for you in the second presentation. So please do not doze off. I will call you out. Okay. Second thing is, on the second presentation, there is a demo that I decided to do in the last minute, which means that first, I have not recorded that. And we know how that can go. And second, if you want to see me nervously laughing, questioning myself, what my life decisions were, trying to figure out why things are not working, that's the best opportunity for you to do that. That will be the highlight of the night. Without further ado, so not that you're too interested about that, but I haven't even said my name. So my name is Paulo Almeida. I write software for fun, and I get paid to do so, which I think is very convenient. I work at Niwa. Raise your hand if you know what Niwa is. Okay, more people than I thought. Okay, so for those who haven't raised his or her hand, Niwa is a Crown Research Institute, so we try to fix problems in nature and protect, New Zealand and the rest of the world. And I specifically work with high performance computing and artificial intelligence. I will talk a little bit about that in the next slide. During my free time, I contribute regularly to the Linux kernel community, mostly for the kernel self-protection project, which is led by Case Cook, which is the security kernel engineer for Google. So basically what we do is, and just kind of trying to paint a picture here. So the kernel has been around for a long time, more than 30 years, and not every line of code there is really secure. So some of those lines can be exploited. So what we do is we recognize patterns of things that could be used as attack vectors, and we go there and harden the Linux kernel at the source code level. So this is what we do, and this is a very interesting place to be. So in case that's your thing, so please join us. There is always a space for one more person. Some of the benefits is you come across pieces of code that you wouldn't normally come across, because that's bugs are everywhere. And second thing is you get to talk to some developers, and you can feel the caliber of the developers that you're talking to. So you get to learn a lot. So it's like you learn for free. It's an amazing opportunity. So if that's your thing, please talk to me after the presentation. What do I do at Niwa? So essentially, like I told you, I work with high performance computing and artificial intelligence. So to translate that into a bit more details, I talk to scientists, people that have dedicated their whole lives trying to fix one particular problem, for like 20 years, but they don't necessarily know how to code. And if they do, that's not exactly the most efficient way, but they need to get an answer. And some of them want to apply artificial intelligence to see if their hypothesis, is worth pursuing. So I get to learn what they have learned in the last 20 years in a compressed manner, and then I translate that into highly optimized source code to run on the high performance computing, which is really good. Like I'm getting paid to study. You never see me complaining about that. One note is, we do operate our own data centers, which is definitely not what you want to hear in this presentation. I know, but a few things. We also are very strong on edge computing, which definitely is really dependent on the cloud. We are making big strides towards quantum computing, and since I joined Niwa, we've been moving a lot of those stuff to the cloud. So it would take some time. When you have many data centers, it takes a little longer for you to move everything, but we will eventually get there. But the message here is, if that's the kind of stuff that you want to work with, we are hiring. Don't forget that. without further ado, let's talk about Lambda custom runtimes. So before I tell you what that is and what you can do with that, I just want to do like a quick recap of how we got there. So Lambda was introduced in 2014. The deployment method is still a zip file containing your code and dependencies, and that's still up to this day limited to 50 megabytes, which for some people that's a lot, and for some people that's just too small. And depending on which programming language you're dealing with, you probably have a different answer. So back in the day, the memory could only go up to 1 gigabyte, which is currently 10 gigabytes, so it's much better. And the maximum time that you could run a Lambda function was for 5 minutes. So this has been changed, now it's 15 minutes. So take a pause to recognize how far we've come so far. But there is one thing. In the past, you were constrained to which runtimes, and when I say runtime, I'm talking about the programming language that you could use on your Lambda function, either Python, Java, and I don't remember all of those that have been released at the time. But you were not only constrained to which of them were available, but most importantly, which versions were available, which is interesting because that creates two interesting problems. So imagine that you were running Java 11, okay? That's good, that's a long-term support version, and again, I do not want to pick on Java, I'm not picking on anyone here, but imagine that Java 12 at the time came along, and there is this new feature that could make your source code look much cleaner, or some new feature that could actually solve one problem that you have. Here's the problem. You are completely dependent on AWS when it comes to when Java 12 could be released. And in fact, there is the possibility that it would never be, because it has to be something that they believe in. That's more work for them to do. So that's one position that you don't want to be in. But there is the other extreme as well. And although this is sad, this is more common than you think. Imagine that you have a piece of code that runs on Java 8, okay? And lots of people have it. And for some reason, you cannot upgrade that to a later version. Whether because that's a licensing issue, or because that doesn't work and you don't have the time to fix it, or the company doesn't have the interest in funding that particular refactoring. These things happen. I still think you have a bigger problem than this, but these things happen. In this case, this is also not a good position to be in, because even though AWS has been conducting backwards compatibility exemplary, you cannot rely on that particular fact alone. They can, and they will, if they want to, stop providing a specific version. And there is nothing you can do about it. That's the deal you've made with them when you signed up to the service, okay? So that takes us to the subject of the first presentation. So Runtime API. So this was announced 4 years after Lambda was announced. So you can use any programming language and share common components, okay? They announced that alongside Lambda layers. We're not going to be talking about that because I think it got superseded by containers, but today we'll be solely focusing on Runtime API. So what that is, it's a simple interface to use any programming language or any specific language version for developing your functions. So what needs to be said here is the following. So when I say API, I mean API endpoints, and by API endpoints, I mean API endpoints are a set of endpoints that a custom runtime can interact with Lambda. A few things you need to notice here. So some of them are optional, some of them are mandatory, okay? We'll talk about each one of them in a second. And the deal is very, very simple. If you can abide by the API contract that AWS provides you with, then you can have some, not all, but some flexibility in the way that you run your source code. And you may be more interested in that than you possibly imagine. But first things first, let's do a crash course on the available APIs, okay? So the extension API, it's there in case you want to gather data about the runtime, okay? So it can either run as the same process or a separate process. When would you want to do that? Here's a suggestion. So you have a piece of code that you can actually run locally, and you know how much memory it consumes, you know how much I/O operations it does. When you put your code on Lambda, you can only look at the logs. If you want to do monitoring on Lambda at the source code level, you need an agent that actually extracts data out of that and pushes to you your observability platform, whether that's Datadog, New Relic, you can choose it. Or even, you know, there are so many others, I'm not gonna start listing them. But for the purpose of this presentation, if you associate extensions API with plugins for Lambda, that's good enough. In fact, if you go to the AWS webpage, there is one thing called Lambda partners, which are, you know, companies that have, you know, created solutions that work out of the box with your Lambda function that can do amazing things for you. There is one in particular that, even though I'm not getting paid to say that, I feel the urge to share that with you. So there is one company called Thundra. Have you heard of them? Yeah, nice. So Thundra has created this mechanism that allows you to set a breakpoint into a Lambda function, and you can debug that locally. And you might be thinking, wow, I can test things locally. Yeah, but your environment is not exactly the same as the Lambda environment. So if you really want to catch that very complicated bug, this is a tool, or that's a card you must have up your sleeve, and that works by integrating with the extensions API. Moving on, the Runtime API. This is the one that we'll be talking at length today. So the way you can, you know, associate the Runtime API with something is to think that Runtime API tells your runtime when it's time to run, and it handles, you know, the request response payloads. This is basically what it does, okay? And the logs/telemetry API, this is usually used in conjunction with the extensions API, the first one that we talked about, but it allows you to get metrics, logs, or platform traces from your Lambda function and push that to third-party endpoints in near real time. So in the past, the only way you could do is to wait for that data to get logged on CloudWatch logs, and then some platform will actually read those logs, parse that, and then you could extract some information out of that. It's actually good enough for a lot of people, okay? And then don't get me wrong, I'm not saying this is bad. I'm just saying that there is a different way of doing that in case you ever need to. So since we're going to talk about Runtime API in details, I need to make a deal with you. I do not need you to remember all the parameters here, but I do need you to memorize 3 endpoints, at least the last segment of them. So the first one is /next, and this is the most complicated one. The reason why we're having this presentation today is because of this endpoint. This one is such an abuse to the HTTP protocol, and you'll see that in a minute. But this is an endpoint that returns a response to your custom runtime when it's time to run your Lambda function. And there's a lot of ways to digest that sentence. The first one is Lambda does not make a request to your custom runtime. You make a request to this endpoint, and you get stalled. Really, that's all it happens. You're not gonna get any response. The connection will be kept open, which is not very usual for a HTTP connectivity. There is so many different ways you can actually keep it, you know, the connection state open. But this is what they do. But when it does return a response, that means someone wants to trigger a Lambda function, and I need you to execute this, or this is the payload, this is the, you know, the ID. Have fun, enjoy. So this is the first one you have to remember, is /next. The second one is /response. Very simple. Basically, whenever your function finishes, you know, its processing, then you get the response and say, hey, /response, here's the answer, give it back to the user, okay? And last but not least, we have this /error, which is almost the exact same thing, but that is for when your function fails to execute. Are we all good? So if you can remember /next, complicated, /response, and /error, you're good to go, really. One mental note here. AWS request ID is written in red for a reason. That's because this is a value that will be obtained when /next returns the response to your custom function. So you have to actually store that somewhere, otherwise you have no way to tell the Lambda service, here's the answer I want you to send back to the user. So that's the first caveat, okay? Next thing, how do we create a custom runtime? And this is actually less complicated than it seems. So the only thing you have to do, which is very different from what you currently do, is you have to have a file called bootstrap. That file doesn't necessarily need to be a binary, it can be a script. There are so many different ways you can actually skin a cat, but the file at the root of your zip file must be called bootstrap, okay? And that bootstrap file is expected to deal with the custom runtime API, which is the announcement we've been talking about. The second thing is, because I'm creating a bash runtime just to give you guys an example, I decided to have my function handler as a separate file. It doesn't have to be, but I think it makes it easier to understand. So it's called function.asset. And its contents is very easy to understand as well. So it's a function that doesn't do much, but it receives a parameter and echo it back to the user. Okay, easy? Basically, I think that's the hello world for Lambda, I would say. All right, disclaimer. The next slide is the most complicated one, but I will tell you everything you need to know, okay? Do not throw tomatoes at me, please. So this is the content of the bootstrap file. So in this case, this is a bash script, but this is what I need you to understand. So the first thing is, this is the request to the /next API that I told you about. And if you see, it's actually written, the HTTP request will block until one response is received, okay? But once this response is received, we're gonna store the data on that particular variable. Then I will extract the Lambda runtime AWS request ID, which is the one that we now know that you need to know in order to send the response back to the Lambda service. RESTful. What can you do about it? And last but not least, I'm actually telling my handler function to process the payload that I just received. Actually, not last but not least, that's the third one. Now is the time to say, last but not least, I'm sending the response back to the user. Okay? Couple of things to say here. Actually, I will say just one, and then I will tell you a little surprising in the next slide. But the one thing here to notice is that you did not see the /error request, which means that this is a functional runtime, custom runtime, but this is not a fully fleshed one. So if your function fails to execute, you have no idea to know why did it fail, and that's horrible. Trust me, been there. When it comes to packaging and deploying your application, this is not very different from the way you normally do, but you have to do two things. First, you have to include the bootstrap file for obvious reasons, but you also have to make sure that your bootstrap file is executable from the POSIX point of view, which is have you ever ch mode plus x? So that's basically what we're talking about here. So after you do that, things become very, very easy, because when you have to deploy your application, your deployment process is not different from what you used to. The only difference is that instead of saying, I want to run Python, I want to run Java, you're going to say, I want to run provided. So this will signal the AWS Lambda service that, I need to execute the bootstrap file. That's the only thing you actually have to do. Now comes the fun part. After you execute that, for the first time, and that's the most important part here, you will see these two pieces of information here. So on the left-hand side, for people that are on the back, I'll actually say the numbers here so you don't have to squeeze your eyes. So, squint. On the left-hand side, we have the init duration, which in this case is 33 milliseconds, not bad at all. And the duration, the duration time or the duration value, which is around 280 milliseconds. One thing I need to emphasize here, this is not technically correct, but for the purposes of this presentation, I want you to assign init duration to cold start. It's very close to be true, but it's not exactly the same thing, okay? So if you run your function twice, you will see the duration value, but not the init value, okay? So whenever you see init value, that's a cold start, and I really want you to know this. So let's compare the Lambda cold starts in different languages and the one we just created. So in the Java, so all the three on the left, they are provided by AWS. The one we created is on the right. So Java took around 450 milliseconds to cold start. A Node took around 150. Python took 100 milliseconds. And our Bash took 33 milliseconds to cold start. So it's not bad at all because we didn't do much, right? But interestingly enough, Bash was the one that took the longest to run the code, which is the red value over there. When you compare that to the other languages, you see that it's around like 20 milliseconds, 1 millisecond, but Bash took 280 milliseconds. So there's a lot to unpack here. The first thing is, Bash was invented so long ago, and this is like nothing humankind has ever invented before. Because this is a fully fledged programming language. You can do pretty much whatever you want to, but it has less responsibilities than other programming languages that we use. And the reason for that is because in the case of Bash, you have the keywords and the specific characters that tells Bash, hey, it's time for you to do something. But in the case of Bash starts kind of adding all the characters it reads on your script, and then when it finds one of those characters that indicates this is time to run, the Bash can make the following decision. Do I know what that means? And if it doesn't know, it basically say, hey, operating system, that's on you. Tell me whatever you want to do with that. Because Bash is also a command executor. So it does not need to parse your source code. That's why the code starts so small in comparison to the others. It doesn't have to parse to see if things work. Try to write a Python file with complete gibberish there and try to run that. It will break before it runs the first line. But if you have a Bash script with 100 lines, and on line 55, you just write complete gibberish. You let your cat on top of your keyboard. The first 54 lines will be executed successfully before you get the error. So that explains a little bit on why we have a small code start. But when it comes to why Bash is so slow, there are good reasons. Because every time I need to run a program, it tells the operating system to run the program. And there's a lot of housekeeping to be done. You allocate memory, you assign a process ID, and then you clean all of that when the process is over. And in the last script, we launched 10 different processes. That's why it takes a long time. So the question that remains is, can we do any better than this? Are there any low-hanging fruits? And it's important to emphasize here that even though we are pushing the limits of Lambda to see how fast we can run things, I'm aware that a lot of companies don't care. A lot of companies will be happy enough if their code start is around 100 milliseconds. So we are doing this just to learn, something more and to have a card up your sleeve. That's the difference between playing and practicing. So now we're practicing, okay? So what are the known overheads? So interpreted programming languages introduce quite some overhead to get started, like Python I mentioned. And there is a lot of housekeeping actions an operating system must handle every time it needs to launch a new process. So we spoke about that. So what can we do differently, and how much can we yield, from it? So no improvements. We can use compiled programming languages because that should give us a boost in performance. Not a big deal, something that's very, very simple. And we can combine, and that's a very interesting one. We can combine the integration with the runtime API and our Lambda code into a single binary. This is a well-known technique if you work with embedded development. Is there anyone here that work with embedded development? Ah, nice. So, have you heard of BusyBox and things like that? Yeah, you probably know why that thing is smaller and sometimes faster. So, this is a very well-known technique, and we can leverage that to see, how far, how much performance improvement we can actually gain. And that takes us to something I'm really proud of. So, not that you need to use it, don't get me wrong. I just did that for fun. That's my pet project. But there are many of there out there, okay? Many of those out there. So I created a C runtime because it kind of, ticks both boxes. That's a compiled language. But I also created that in a way that when it compiles, it actually compiles everything into a single binary. So the way you need to understand that if you're not a C developer is, this is how you include the library into your application. I will provide you with the handler method signature, very similar to the way you would get if you were using the official runtimes provided by Amazon, which is, request, response. Maybe I could add context, but I think you can get everything you want to from request. You can tell that the response is either successful or fail by choosing one of those methods available. So in this case, that's success. And the most important part is the main entry point. So that's the run handler. What it does is it starts integrating or communicating with the runtime API, and only when it's time to run our function, then it does it. That's all you need to know about that, okay? But what do we get? So that's very different actually. So the code start for my C runtime, and let me emphasize that enough. This is not an official project. That's my pet project. It took me 4 hours to develop this. Okay, so my code start is 13 milliseconds, very close to one single digit of millisecond. That's good, and my duration is 1 millisecond. So the interesting thing is when you stack them together, you can barely see the C runtime there. It's actually, if you remove the bash from the equation, because that was just an example, it's actually almost 8 times faster than the one provided by AWS. And we didn't do much. We just, ripped the low-hanging fruits. Okay? Now.
So I have a question. So where is this bootstrap provided? So you said that we need a bootstrap. Is this compiled into bootstrap?
Yeah, I compile into a bootstrap. Yeah.
And what does the API cost? Because that wasn't in the prompt.
So the API calls is actually the implementation of the method run handler. Because that's a framework, so which is included by this header at the top. Yeah. Okay. I can share with you the link of the GitHub, but there are more examples with all the details.
So that runtime.h has multiple language support?
Which one?
The runtime.h. Like
The one from AWS or the one I just showed you?
from AWS.
Oh, you can run anything. As long as you can provide a file called Bootstrap, you can use that can be written in any programming language of your choice, of course, and you can actually trigger any binary that you want to. So as long as you can compile that, or you can carry all the dependencies with you, and you have the bootstrap file, then it will work. Okay. The only penalty is that you have to communicate using the runtime API contract, which is something that's not too worrying, but this is actually the slide that I was about to tell you. So. Dealing with the runtime API is not hard per se, because there are only 3 endpoints. It's not really hard. But you cannot forget that these API contracts may change. So you have to account for some time to maintain that, so it can become like a project of yours. Certain companies will actually say, okay, we can do that, because if my code runs in less time, I can actually do certain businesses. But I'm not a hypocrite to say that a lot of companies will say, you know what, I'm actually concerned about how much Lambda costs. So because of that, maybe they're not gonna let you to write a custom runtime. But again, this is just a technique that you may have up your sleeve. So one use case that I believe you all can relate. So whenever you access a website and you see ads, those ad servers have 100 milliseconds to make the decision and serve the content. So if you actually think about that, that's such a small amount of time, to actually do everything. So you have to squeeze every single drop of performance that you can. And being able to run that on Lambda is actually quite enticing. So maybe if you work for that kind of industry, that would be really relevant for you. And the second takeaway is custom runtimes are useful for performance optimization, and that's not exclusive, overall flexibility on how you run your code. So if you want to run Java 8 at your own risk, because that's not going to be patched anymore, you can bring that. So that's something to think about. And with that, that's time for the break time. So this is how it's going to work. I do have a Q&A session at the end of the second presentation, but during the break time that we'll get something to drink, to eat, we can have some more unofficial Q&A as we drink and eat. All right. Thank you very much. I'll talk to you in a minute.